Displacement and velocity. Today's goal is to learn the differences between speed and velocity, and also the difference between distance and displacement. The big idea here is that both displacement and velocity indicate a direction of motion, whereas the words distance and speed do not. Oftentimes in the English language we use velocity and speed as synonyms, but in physics they are slightly different. Velocity has the extra information of direction. Number 1, define. Coordinate systems are basically number lines or graphs that are used to measure the locations of objects. The exact location of the origin is completely flexible. The direction of the positive and negative is also flexible. So whenever we have a story problem in this chapter and following chapters, it's going to be really good to draw a little picture of the situation so that we can get a better understanding as to what's going on. And in this picture, we're going to label some location as being the origin or 0. And with number lines in our previous math classes and graphs, there's always to the right is positive, and going up is also positive. Going down or to the left is negative. Now, the same kind of a thing is going to be happening here in physics, although we can do it the opposite if we'd like. Sometimes it may be more convenient to have things going to the left being positive, and we have that flexibility. Number 2. Before I go on to number 2, the way that we're going to be showing the coordinate system is with a little symbol like this in our pictures. We're going to have a 0 indicating where everything is measured from, and which direction is positive and negative. Now, it is a custom or a tradition for things to be positive in the right, negative to the left, but as I've mentioned just a moment ago, that's just a custom and it's not a firm rule. We can have things opposite if we'd like. But it's customary to have things going to the right or above the origin being positive. The variable x usually indicates the location of an object. Well, we can have other variables, but this is the one that we're going to be using consistently throughout this class. Now, when we have objects moving around, we have different x values, and we have to make sure that we keep those straight. And so we have added little subscript letters or numbers to the variable x to keep one location separate from another. For instance, x with a subscript I or x with a subscript 1 will be the initial location. X subscript f, x subscript 2 is the final location. We could have others as well. X sub 3, x subscript 4. I've even seen subscripts of a's and b's and c's. But these are the ones that I'm going to be using most often. And to shorten things up, instead of saying x subscript f, I'll just say x sub f or x sub 2. The change in location is a triangle x, read delta x. And delta is a symbol used for change in. You may have seen it in chemistry class with a delta capital T, which means change in temperature. We could have change in just about any variable at all. A fancy term for the change in x is displacement. And the way that we find this is either x sub f minus x sub I or x sub 2 minus x sub 1. Now, these two equations are saying the exact same thing, it's just that I have different subscripts. Whenever you have a delta variable, it's always the final value minus the initial value. Okay, let's use those equations to solve these problems. Draw arrows from the starting point to the ending point, then find delta x. So here in problem number 4, we have x sub I is at the 6 meter mark. X sub f, the final location, is at the 11 meter mark. So that means that an object is moving to the right. We find delta x then by the final location minus the initial location. 11 minus 6. So we get a positive 5. In problem number 5, it starts off at the 9 meter mark. and the object ends at the 6 meter mark. And so to find the delta x here, it's going to be 6 minus 9 meters. We get a negative value for delta x. The displacement is a negative 3 meters. Number 6. The initial location is at negative 3. The final location is at negative 8. So the object is moving to the left. When we do the final minus the initial, we end up with a double negative sign in between here. So be careful when you do your math. We end up with a negative 5 meters for the displacement. Now notice here that sometimes we get a negative value for the displacement, sometimes it's positive. There is a pattern here. Line number 7. The displacement delta x is just the distance traveled with a sign indicating which direction the object is going. So if the object is going in the left, it's going to be a negative displacement. If it's going to the right, it's a positive displacement. Now that is assuming the traditional coordinate system where the positives are going to the right. The equation for average velocity is bar v, that's a bar above the letter v, equals delta x over t. Now its average is important to say here because during a certain time of travel it might be speeding up and slowing down slightly, so we're just finding the average speed. Now this equation here looks rather similar to an equation that you had in junior high, s equals d over t. You may have seen this equation in math classes as well. They're saying basically the same thing, but it's a little bit different. In this equation with the s and d, those letters are always positive, whereas the delta x and the v can be negative. If the object is moving to the left in the traditional coordinate system, then the x and the v are negatives. So that's line number 10. If it's moving left or if it's moving down. So, line number 11. Velocity is not a synonym for speed. Velocity is speed plus direction. And the positive means that it's going right or going up. A negative velocity means that it's going down or to the left. Again, this is assuming the traditional coordinate system. Every once in a while, we'll have things reversed, and we'll have to keep that in mind when we interpret our results. So these things of displacement and velocity, these things that have both a size and a direction, those are called vectors. The size of the displacement vector is how far it's going. The size of the velocity vector is how fast it's going. And both of these things also tell us the direction of motion. So vectors tell us size and direction. The other things that we talked about today, speed and distance, they just tell us how far or how fast. They don't tell us which way they're going. So those are called scalars. Line number 12. How long would it take a car to go 16 kilometers if it traveled 45 miles per hour? Now right away, we can see that we have different units here for the measurement of length. And we can't keep those and solve this problem properly. We have to convert them to be compatible. So I'm going to change the 16 kilometers to be 10 miles. I could have changed the miles over here if I wanted to. It doesn't really matter. Okay, so the first thing that we're going to do is to assign the variables to each one of these numbers. The 10 miles is how far it traveled, the displacement. The 45 is the average velocity. That's all the numbers that we know. The next thing we have to figure out is what variable are we trying to figure out? The question is asking how long would it take? So we're looking for a time, and that's the variable t. The next step is to write down our equation that relates the known things to the unknown thing. We call that the raw equation. That's the equation with just the letters in it. Bar v equals delta x over t. And now I can substitute in my numbers. The 10 goes into the delta x on the top. The 45 goes in for the v on the left-hand side. And the t that I'm looking for stays a letter. Now, a lot of people try to solve this incorrectly. They want to get the t by itself, and so they decide to divide both sides by 10, and they get the answer of 4.5. That would be wrong. The reason is that the t is at the denominator here, not on the top. So we don't just simply divide by 10. Perhaps the way that's easiest for students to do is to make the left-hand side a fraction as well, and then cross multiply and divide. And the answer then is 0.22 hours. When you do the algebra, the miles are going to cancel out, leaving just the hours for our answer. Extra discussion. Imagine that you're in a focus group that is being asked questions by a car company. A lot of companies use something called a focus group. That's a small group of people, about 10 folks, who gather in a room and they're asked very, very specific questions over a significant period of time, an hour, hour and a half. And the company really tries to figure out how a certain product or how a certain advertising campaign is perceived by people. Anyway, the company asked this focus group if they should have a dashboard on their cars indicating speed or velocity. What would you say? Go ahead and write your answer in your packet at this time. Think about your learning. What do you think are the two most important lines in the notes? Before you go back and make indications of that, what I want you to do is to go to your unit organizer on the front of your packet, just inside the front cover, and look at the questions at the bottom. Those are the most important questions that you need to be able to answer in this chapter. Do any of these questions get answered in this lesson here? Please find out which ones do and write their answers in on your unit organizer. Include stars on your notes, or circle the most important lines in your notes. Somehow indicate those so that when you're studying for your test, you can zero in on the most important ideas really easily. And that's the end of this lesson.